The first shortcut trick which we come across here, short trick 1. This says the x coordinates of 2 points A and B are the roots of the equation px square plus qx plus r equal to 0 and y coordinates of 2 points A and B are the roots of the equation a y square plus by plus c equal to 0. Then to find the equation of a circle, with AB as diameter, in both quadratic equation, we first of all make the coefficient of x square and y square as 1, and finally we add them to get the required equation of the circle. So here the x coordinate of the 2 points A and B are the roots of this equation, this quadratic equation, and y ordinate the roots of this quadratic equation. Now to find the equation of a circle with AB as diameter, what we do? In both the quadratic equation, we make the coefficient of x square and y square as 1, and then we add the two equations. That is what we do. First of all, we had the equation px square plus qx plus r equal to 0. To make the coefficient of x square as 1, we divide by p. So if we divide by p, we get x square plus q by p into x plus r by p equal to 0. This we have as one equation, which we mark as equation 1. Other one, ax square plus bx plus c equal to 0. Here you divide by a plus c by a equal to 0. This is equation 2. Now what we do? To get the equation of circle, we add. And what we get? We get here x square plus y square plus q by px plus b by a into x plus r by p plus c by a equal to 0. Very simple. So this is the technique which will be applying as shortcut method. And the logic behind this technique also we will understand. Now we will take the first question, where it is given that abscissa, that is x coordinate, of 2 points, x coordinates of two diametric endpoints of a circle are the roots of quadratic equation x square plus 2x minus a square equal to 0. And y coordinates of 2 points of these points are the roots of y square plus 4y minus b square equal to 0. So here the plus point is what? We can see that here the coefficient of x square and coefficient of y square is 1 only. So to get the equation of circle, simply add these two. So equation of the circle is equal to x square plus y square plus 2x plus 4y minus a square minus b square equal to 0. So this is the equation of the circle which we get. Now what you have to find out here? Just the equation which you have already got. Now if you want to just compare with the given expression and according to the option, then what we can write? It is x plus 1 whole square plus y plus 2 whole square equal to, we get here a square plus b square plus 5. Now we come to the proper method of solving this one. That is when we have written exam, then how to proceed. For this, at first we have taken here a circle whose diametric ends are given. That is, here you have the point A, which is x1 comma y1. Here you have the point B, which is x2 y2. Now, if we write the equation of this circle, we know for writing the equation we have to take here arbitrary point P x comma y on the circle. So equation of the circle is given by x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. Now, if we simplify this expression, then what we get? It is x square minus x into x1 plus x2 plus x1 x2 plus y square minus y into y1 plus y2 plus y1 y2 equal to 0. So this is what we have got. Now, if we observe carefully, this is what sum of the roots. Sum of the roots means when we have the diametric and A and B, the sum of x1 and x2, and the product of the root of these two root only we are talking about. Now, given this, we mark as equation 1 and we take the given expression. Now, given is what? Given information that here abscissa of A and B, that is the x coordinates of A and B are the roots of the equation x square plus 2x minus a square equal to 0. Now here x1 plus x2 equal to minus b by a. that is minus 2, and x1 into x2 equal to minus a square. Similarly, it is given that y coordinates of a and b are the roots of the equation y square plus 4y minus b square equal to 0. Now from this what we can say? Therefore y1 plus y2 equal to minus b by a, and y1 into y2 equal to minus b square. So this is what we have got. Now what we'll do, we'll simply substitute these values in this equation 1 and we are done. So we can say on substituting these values in 1, what we get? We get here x square plus y square minus x into this. So x1 plus x2, that is minus 2 here. So it will be plus 2x. For the root minus a square. Now here if we put minus again, so this will be minus into minus plus 4y. And then what we have, minus b square equal to 0. So this is how we get the expression. Now to match with the MCQs here given, what we can do, we can simplify this one and we get here x plus 1 whole square plus y plus 2 whole square equal to 5 plus a square plus b square. Here it is given that abscissa of two diametric ends of a circle are the roots of the quadratic expression, quadratic equation x square plus twice x minus b square equal to 0, and ordinates of these points are the roots of the quadratic equation y square plus 2py minus q square equal to 0. We have to find the radius of a circle whose diametric ends we are taken. Now, equation of circle we can write by using shortcut technique. That is equation of circle is x square plus y square plus twice x plus twice py minus b square minus q square equal to 0. Now, since we have to find the radius here, so we try to bring it in the proper format. X plus a whole square plus y plus p whole square equal to, we have taken here a square and p square extra, so we'll return that. So on simplification, we get this one. Now we can rewrite this as a square plus b square plus p square plus q square whole square. Now this is in accordance with the formula x minus x1 whole square plus y minus y whole square equal to r square. So from that we can easily understand that therefore radius is equal to under root of a square plus b square plus p square plus q square. That is what we need. We come to next short trick. Short trick 2. Now here what does it say? That locus of the midpoints of the chord of a circle whose equation is given by x minus h whole square plus y minus k whole square equal to r square, subtending an angle theta at the center is x minus h whole square plus y minus k whole square equal to r square cos square theta by 2. So the locus of the midpoint of the chord of a circle, this one, subtending angle theta at the center is given by this one. This is a short trick which we have. We'll be applying this technique and then we'll go to the explanation of this technique. Here it is given that equation of circle is x square plus y square equal to 25, that is 5 square. Now, if we take here the circle, here we have a particular chord AB. Here we have the center, which is 0, 0. Here it is subtending an angle of theta. Now, what we have to find? The locus of the midpoint. Midpoint here is M. So we can write the locus of the midpoint of the chord. Midpoint of the chord is x minus 0 whole square plus y minus 0 whole square equal to r square cos square theta by 2. Here we know what is r. Here r is 5, so it is 5 square. Cos square theta by 2. Theta is given here as 90 degree. So that means here cos square pi by 4 will give. So that will be 25 by 2. So ultimately what we get, that required locus is x square plus y square equal to 25 by 2. In the proper method, we will take the generalized values, that is just theta and r only, that is to consider equation of circle as x minus h whole square plus y minus k whole square equal to r square. Chord whose locus subtends an angle of theta. Now, if it is subtending an angle of theta, then what is the locus to midpoint? So we just take the circle here. We take a chord. We take here the center C. Now this is the midpoint M. A and B. The total angle is theta. So we can easily understand that here triangle ACM and triangle BCM are congruent. Why congruent? We can easily say by RH's axiom of congruency. Why? We have here 90 degree because we know when we join the center of the circle to the midpoint of any chord, then that angle should be equal to 90 degree. So in that respect, what we can say that this will be RHS axiom. We can say these two are congruent. Why? 90 common side, this equal to this, and we know it will bisect also, so this equal to this also. Now after that, what we can say that therefore, or this implies angle ACM equal to angle BCM, CPC, corresponding part of congruent triangle. So this will be equal to what? Theta by 2. Now we know AC and BC is radius, which is R. Now we focus on the triangle. From triangle ACM, we say cos theta by 2 equal to CM by R. Now from this, what we say that CM equal to R cos theta by. Now what is CM? Distance formula we can apply here. Center is here H comma K, and the point M we take as x1 comma y1. That is any arbitrary point we have taken x1 comma y1. Now from here we can say that x1 minus h whole square plus y1 minus k whole square equal to what we have here r cos theta by 2. Now we'll square this. After squaring we get x1 minus h whole square plus y1 minus k whole square equal to r square cos square theta by 2. Now, when you want to get the locus, then you have to replace this x1, y1 by the current coordinate. So, what is say here? On replacing x1, comma y1 by the current coordinate x comma y, we get the required locus, which is x minus h whole square plus y minus k whole square equal to r square cos square theta by 2, which is the required locus in the generalized form. Here it is given that center of the circle is C, which is 0, 0. Radius of the circle is 3 unit. Now, if we just decode this information here, then we can understand that here we have to take a chord which we take as A, B. Center is C, which is 0, 0. Radius is given, which is 3 unit. That is here we can see radius is AC equal to BC, 3 unit. And the angle ACB equal to 2 pi by 3. Now that is the total angle which we have to. This is the total angle ACB which we have is this one, or we can say according to the shortcut it is theta. Now locus of the midpoint. Midpoint means here midpoint of the chord. So here we have this point as M. So locus of the midpoint, locus of the midpoints of the chord AB is x minus 0 whole square plus y minus 0 whole square equal to r square. R is here 3 square cos square pi by 3. Actually 2 pi by 3 by 2, and we get that one as pi by 3. Now from this what we get, that is equal to 9 by 4, because cos pi by 3 is half, square 9 by 4. So therefore the required locus which we get is x square plus y square equal to 9 by 4. We move on to next question, but before that we have to know a very important tip here, that is or you can say very important result here. So we take here a very important result of a particular theory. It says that if the circle whose equation is given by S1 equal to 0 bisects the circumference of the circle, bisects the circumference of the circle whose equation is given by S2 equal to 0, then their common chord will be the diameter of of the circle whose equation is given by S2 equal to 0. That is, if we try to understand the whole concept once again, this is a circle whose equation is S2 equal to 0. There is another circle which is bisecting the circumference of this circle. Is this one? Bisecting the circumference of this circle is this one. This equation is S1 equal to 0. Now what they're saying, that they will definitely have a common chord, which you can see in this case, this one, which you take as A and B. These AB will be the diameter of S2. That means we can say that AB will pass through the center of the circle S2 equal to 0. So this is the concept which has been given, very important concept here. We can just apply this concept in that is given as there is an equation of a circle, equation of a circle, which we take here as S1, and that is x square plus y square plus 3x minus 4y plus a equal to 0. Now this one is bisecting another circle, bisects the circumference of the circle S2. Now what is S2 here? It is x square plus y square minus 2x minus 2y plus b equal to 0. Now this circle bisects the circumference of this circle. Then this is S2 equal to 0. Now what we have learned just now, that is the common chord of these two circles will pass through the center of this circle. So first of all, we try to find the center of S2. So for that, we can just compare this equation with the general equation of circle. Now from this, what we understand, that 2g equal to minus 2. So g equal to minus 1 and 2f equal to minus 2, f equal to minus 1. So what is center? Center minus g comma minus. That is what? That is 1 comma 1. So this is the center of the circle S2. Now we'll find the equation of common chord. So equation of common chord we know is given by S1 minus S2 equal to 0. So from that what we get? If we subtract this one, we get 5x minus 2y plus a minus b equal to 0. Just we are separating this two equation, x square and y square will get eliminated, we'll get a linear equation, and that will be the equation of a common chord. These will pass through the center, that is 1 comma 1. So what we get, 5 minus 2 plus a minus b equal to 0. And this gives us that a minus b plus c equal to 0, which is the required condition here, or you can say required relation between a, b, and the constant. We can say better to say relation between a and b. Next is shortcut trick here. Now, what does it say? That two lines, two lines meeting the coordinate axis, meeting the coordinate axis at 4 points which are consecutive, then the product of, then the product of x intercepts and y intercepts are equal. So two lines meaning the point axis at 4 points which are consecutive, then the product of the x intercept and the y intercept are equal. Now let us understand this. For that we take a Cartesian plane, y is x, this is x prime, this is y prime, this is origin. We take here two lines. One is this one, another we take as this one. Now we take a circle also. This one. We have taken here in such a way that this circle passes through the 4 points where the lines are meeting the coordinate axis. It is given in the theory that the lines are meeting the coordinate axis at the consecutive point. The lines are meeting the coordinate axis at consecutive points. Then what will happen? Then we can say OA into OB equal to OC into OD. Then we can say that OA into OB equal to OC into OD. So this is the technique. Now the question is, how is this technique true? How to understand the shortcut technique we have understood. Let us understand this one more clearly. Here we take this line as L1 and this line as L2. Now equation of L1, equation of L1 we take as a1x plus b1y equal to 1, and equation of L2 we take as a2x plus b2y equal to 1. So these are the two line equation we have taken. Now first of all we'll find here a and b. We can find by putting just y equal to 0 here, and we get the value of a, coordinate of a, I mean to say. Similarly, we can find the point b by putting y equal to 0 here. That is, for a, we have 1 by a1 comma 0. For b, we have 1 by a2 comma 0. Similarly, For C, we'll put x equal to 0, so it is 0, comma 1 by B1 and D 0, comma 1 by B2. So we got the points. Now the circle is passing through these points. Now first of all, we take the general equation of circle. That is, let equation of circle be x square plus y square plus 2gx plus 2fy plus c equal to 0. Now for the point A and B, if we just consider the point C and B, for A and B, what we can say that y should be 0. Now when y is 0, what we get? X square plus 2gx plus c equal to 0. We get a quadratic equation. Now this equation will have two roots. These two roots are 1 by a1 and 1 by a2. So from here what we can say that therefore 1 by a1 into 1 by a2 equal to c by 1, and we mark this as equation 1. Now similarly, for the point C and D, x is 0. So in the equation of circle, we put x equal to 0. So you can say that for the points C and D, we put x equal to 0. So what we get? Y square plus 2fy plus c equal to 0. Now this will have two roots. What are the roots? It is 1 by b1 into 1 by b2, which will be equal to c, and that will mark as equation 2. So from 1 and 2, what we can say that 1 by a1 into 1 by a2 equal to 1 by b1 into 1 by b2. Now, if we observe carefully, this 1 by a1 is actually x-intercept, and this is also the x-intercept. For this is the x-intercept for the line L1, this is the x-intercept for the line L2. Similarly, this is the y-intercept for the line L1, this is the y-intercept for the line L2. Now, this shows that product of x-intercepts of the lines is equal to product of y-intercepts of the lines.
Given the lines x minus 2y plus 3 equal to 0 and 3x plus ky plus 7 equal to 0, cut the coordinate axis in concyclic points.
So first of all, what we do, since it is given in accordance with the concept that when the lines cut the coordinates in the concyclic point part of the x-intercept equal part of the y-intercept. So first of all, we try to bring the first line in the intercept form to understand that what is the x-intercept of the line and what is the y-intercept. So this is the first line. And the second line, what we have, 3x plus ky equal to minus 7. Now from this, we can say that x by minus 7 by 3 plus y by minus 7 by k equal to 1. So we can get here the x-intercepts as well as the y-intercept. So as per the technique here, the product of x-intercepts of the lines is equal to product of y-intercepts of the lines. Now here, just we'll apply this. We'll substitute this for values. Minus 7 by 3 equal to 3 by 2 into minus 7 by k. Now from here, what we understand, minus minus cancel out, we are left with only one minus sign here. Now here, these three will get cancelled out. So ultimately we get here k, which is minus 3 by 2. We come to another very important result. A very important result here. This says the length of common chord of the circles whose equations are x square plus y square plus x plus by plus c equal to 0 and x square plus y square plus bx plus ay plus c equal to 0 is given by under root of 1 by 2 into a plus b whole square minus 4c. So this is given that if we have this equation, then we can get the common chord, length of the common chord by this formula. How it is coming? Let us understand this. We take here two circles. This is S1 equal to 0 we take, and is S2 equal to 0. Here S1 denotes the first circle and S2 denotes the second circle. That is what we mean to say that here S1 is x square plus y square plus ax plus by plus c equal to 0. And S2 is x square plus y square plus bx plus ay plus c equal to 0. Now, simply we'll compare these equations with the general equations x square plus y square plus 2gx plus 2fy plus c equal to 0. Now then, for the center of the first circle, we understand it is minus a by 2 comma minus b by 2, and radius here we are getting under root of a square by 4 plus b square by 4 minus c. Similarly, the center of the second circle we get as minus b by 2 minus a by 2, and the radius here, that is under root of a square by 4 plus b square by 4 minus c. So we got the center of the two circle as well as their corresponding radius. Now here we understand that these two circles definitely have a common chord, which will be AB. Now we can find the equation of the common chord. So equation of common chord is S1 minus S2 equal to 0. Now from this what we get, A minus B into X plus B minus A into Y equal to 0, which we can further simplify as A minus B into X minus Y equal to 0. So what we get here, that X minus Y equal to 0, because A and B not equal, because when A and B are equal, this is the same circle. So we got the equation of AB. Now from here we can find the distance of the center from the common chord, which I take as CD. And here we have the radius. Radius already we know is the radius. And the radius for both the circle is same thing only. So we know the length of AC. What we need? Length of CD. Because if we know the length of CD, then we can find AD. Once we know AD, then twice of AD will be the length of the common chord. So next our intention is to get the length of CD. What is the length of CD? Length of CD is the perpendicular distance of the center from the common chord. So that we can find out very easily because we know the equation of common chord as well as we know the center. So here we can write that minus a by 2 plus b by 2 by root over of 1 plus 1. Now this will be b minus a by 2 root 2. Now from this we can find the length of AD. What is length of AD? That is under root of AC square, AC1 actually, because we have taken the center as C1, AC1 square minus C1 d square. So this is A square by 4 plus B square by 4 minus C minus CD square, that is B minus A by 2 root 2 whole square. So you simplify here and we get A square by 4 plus B square by 4 minus C minus A square by 8 minus B square by 8 plus AB by 4. Now we simplify this one. So it is, we can understand here that here we have 4, here we have 8. So if we simplify, this will be ultimately A square by 8 plus B square by 8 plus AB by 4 minus C. So we take under root of 1 by 8 common. So A square plus B square plus 2AB minus C. So from that we get under root of 1 by 8 A plus B whole square minus C. Now we take here a 4 common. So this will be 1 by 2 A plus B whole square minus 4C. Now this is the length of AD which we have got. Now our intention is to get the length of the common chord. So we have to multiply this by 2. So that is the length of AB. So you can say here length of AB is twice AD, which is under root of 1 by 2 A plus B whole square minus 4C. So that is what we need to find out. Now, if we apply this concept in the next sum, then it is very simple. The equation of circles given in the next sum, that is given equation of circles, are first one x square plus y square plus 2x plus 3y plus 2 equal to 0. This is one circle. Another one x square plus y square plus 3x plus 2y plus 2 equal to 0. So basically, if we take this one as A, this one as B, this one as C, then it is B, A, C. So same thing. So just we'll apply this concept and we can get that length of common chord will be equal to root under of half of 2 plus 3 whole square minus 4 into 2. Now that is root under of 1 by 2 into 25 minus 8. Now that gives us root over of 9 by root 2. So that is 3 by root 2 unit. Important result. If the tangents to the curve x square plus y square equal to a square at the point p comma q meets the coordinate axis. Meets the coordinate axis at the points A and B. O with the origin. That is, we take O as the origin. Then area of the triangle. Then area of the triangle AOB is given by A to the power of 4 by twice P into Q. That is, if we draw the tangent to the circle at this point, and it means the coordinate axis A and B. So if we just draw to understand, it is the coordinate axis we are taking. We take here a circle. Here it is y-axis, x prime, origin y prime. Here the equation of the circle is x square plus y square equal to a square. That is, here the radius which we have is a comma 0, definitely. So this length will be a unit. Now at a particular point the tangent is drawn. So we take this point as P comma Q. Now here if we take a tangent, the tangent. Now here the tangent is drawn at this point and it is meeting at the 2 points which we take here as A, because it is given A and B. So we take this point which we have taken initially A1. Now the point we take as A and this point we take as B. Now we are talking about the triangle AOB. This point is taken as A1 because both cannot be A. So the triangle AOB will be this one. Area of the triangle AOB will be a to the power of 4 by twice PQ. We can prove this very easily. And we take here one example also. That is equation of circle. Equation of circle. P x square plus y square equal to 5 square. Tangent is drawn. There is a point of contact which they are talking about, or the tangent is drawn. Point of contact P is 3, 4. Therefore, you can find the area now. Now, area is given by area of triangle. Area of triangle AOB is given by 5 to the power of 4 because here radius is A, so it's 8 to the power of 4 divided by 2 times 3 into 4. Now that gives us 625 by 24 square unit. Now, first of all, we just recollect the concept of derivative of it. This is x prime, this is y prime, this is origin. Here we know that if we have a function which is continuous function and differentiable, then if we want to get the slope of the curve at a particular point, we can just find the derivative of the function at that point. And at this point, slope of the tangent and slope of the curve is same. So what we can see, that slope of the curve at the point P x1, y1 equal to slope of tangent at the point P x1, y1, and that is equal to ddx of y at x1, y1. Just we'll differentiate and we'll get this, which is f dash x1. Now that is what we get. Now equation of the tangent, if we want to find equation of tangent line. Now that we can write y minus y1 equal to f dash x1 into x minus x1. Now we take a equation of circle, which is x square plus y square equal to a square. And for this circle, we want to know the equation of tangent drawn at the point x1 comma y1. If we take this circle and we try to find the tangent at this point x1 comma y1, this point where the tangent is drawn, it has a particular name which is called point of contact. This is called point of contact. Now this is a tangent line which you have to find, whose equation you have to find. So first of all, we differentiate this equation because we need dx of point. So on differentiating, the upper part of the curve, what we get? We get that dx of y equal to minus x by 1. Therefore, dx of y at x1 comma y1 minus x1 by y1. Now we'll find the equation of tangent line. Now equation of tangent line. Now y minus y1 is minus x1 by y1 into x minus x1, which gives us y1 plus x1 equal to x1 square plus y1 square. Now we think another very important logic here. There is this point of contact lies on the circle, so it must satisfy the equation of the circle. There is a point of contact should satisfy the equation of circle. So you can write this one as a square. Why? As point of contact lies on the circle, so must satisfy the equation of the circle. And therefore, what we say that x1 square plus y1 square equal to a square, which we have utilized. So ultimately, the equation of tangent which we have got is x1 plus y1 equal to a square. Now, how to remember? For remembering point of view, it is very simple. Equation was x square plus y square equal to a square. Just you break that x square as x into x1. You break the, or you can say split up the y square as y into y1 equal to a square. So that is how we have got the equation of tangent. Now this tangent will have some x-intercept and y-intercept. That is, this tangent which we have drawn here is definitely have some x-intercept. So x-intercept will be OA and y-intercept is OB. Now you want to find A first. How to find A? For A, y is 0. That is, I mean to say ordinate is 0. So if we put here 0, then we'll get what? Abscissa of A. So A into A, that is A abscissa of x into x1 plus 0 equal to A square. Now this gives us an abscissa of A equal to A square by x1. Similarly, for the point B, which is 0 comma ordinate of B. So that will be 0 plus y1 into ordinate of B equal to A square. Now this gives us that ordinate of b equal to a square by y1. Now what is our intention? To get the area of the triangle here. So that will be half into base into height. So for that what we get? That therefore area of triangle OAB equal to half into a square by x1 into a square by y1. So that is a to the power of 4 by twice x1 y1. Important result. It says that the length of a side of an equilateral triangle inscribed in a circle x square plus y square equal to a square, that is here a is the radius of the circle, is given by root 3a. Now we'll understand the logic behind this. We take here a circle whose equation is given by x square plus a square, x square plus y square equal to a square. A center, this is y prime. The center, this is y prime. This is a comma 0. Now we take here an equilateral triangle. We can take a special point also, but that is actually is not required, because here if we take this one as P, this as Q, this as R, OP length is equal to A, equal to OQ. Now here you have this length 30 degree and this is L. Now what we can find here, that from triangle OQL, we can say here that sine 30 degree equal to OL by A. So OL equal to A by 2. Now what we need? We need PL. PL equal to OP plus OL. A plus A by 2 equal to 3A by 2. From triangle PQL, what we get? We get here the sine 60 degree equal to PL by PQ. PQ is the length of the side which is actually required here. So that will be PL. PL already we have got 3A by 2. Now here sine 60 root 3 by 2. So ultimately is root 3A. So that is the length of the side of the equilateral triangle. We take this one of the application. The length of the side of an equilateral triangle inscribed in a circle whose equation is x square plus y square equal to 100. Now very simple, just we can compare this with x square plus y square equal to a square, and therefore a equal to 10 unit. Therefore length of side is given by root 3a. So 10 root 3 unit. So it's just a matter of one line. If we know the shortcut, we can apply and get the result in no time.